Hello, everyone. Welcome. It's now the Siemens presentation time. Welcome. I'm Guillaume Fauconnier, part of the French organization as a technical account manager.
Hello, everyone. My name is Shivdeep. I'm looking at things more globally. Sorry to disappoint you. John Nixon couldn't be here, so that's basically. So I'm going to be doing this in his place. So yeah, I'm looking at the global organization specifically for energy when it comes to simulations in Siemens.
We'll speak today about how we plan to accelerate the nuclear industry thanks to digital solution. If it's working.
All right. So overall, we see a lot of trends in the market, and I'll start with this. Energy efficiency, aging assets, the time to market for new technologies, so things like the Gen 4 reactors, all of these things are things where we are working on. And to be doing this not just at speed, but also doing it sustainably. And on the demand side, we see that it's already was on the rise, but with the new demands, especially from the the data side, the demand is even picked up. So there is a lot of focus on the nuclear energy as a reliable source of energy for the future. I'll let Guillaume next.
Yeah. So our mission at Siemens is to provide a solution to our customer to become a digital enterprise by really mixing both real and digital twin. Several topics there. First, the convergence from the OT to the IT. The goal is to really make that link, that data flow from the floor, from the data acquisition system, that could be really diverse, and map this data to the IT system from the engineering to the simulation. Another aspect really important is the cybersecurity, both for OT and also for IT, because the IP, the sovereignty of the data is really key. And another point on my side, which is the fact we need to consider the ecosystem. Our customer work in a large environment in an extended enterprise mode, and we provide interoperable and open platforms so they can work with our tools, of course, but third-party tools too.
Yeah, and to make this all comprehensive, so what does actually comprehensive mean? The term digital twin is something that is used very often. But really it depends on the kind of question you want an answer to that the digital twin has to provide. So when we say comprehensive, really it really digs down all the way down to the depths of the physics, all the way to your supply chain, to your entire network of providers and so on. And the same with AI actually also. So there's a lot of benefits to be gained from the AI side. And I'll show some use cases later on in this presentation today. But just to show off hands, I know we are all a little bit tired in the evening. Anyone heard the jellyfish news? So the nuclear reactor being paused because of jellyfish entering the cooling systems. It's quite recent, look it up, there's something like that happened. So, and it's not only a problem in the nuclear industry. This is something that is anywhere we have an asset-heavy thing, especially close to the oceans, close to the seas. And I'll show a use case where we have something of these kind of technologies, especially bridging AI, IT, and OT, getting into a place where it can actually deliver a lot of benefit for the customer. So hold on for that, and back to you, Guillaume.
As you said, we are really involved in AI. AI, first, according to me, there is no AI without data. And at Siemens, we are investing a lot. Actually, we are #1 in patents in Europe on AI technology. And this AI stack is really at every level, from the authoring tool, design simulation, in data management, and also on the data analytics. And we are able to combine diverse AI technologies in order to make it robust and industrial. That's really the key thing we wanted to say here. It's an industrial grade solution that we propose and develop here at Siemens. Sorry. We'll now go through the life cycle of a project that could be a product-oriented life cycle, or it could be a plant-oriented life cycle. And every project starts with project definition, and a nice and good project definition starts with reuse. You don't start from scratch, from the white blank. You start by reusing what you have. And for nice and good reuse process, the information search and access is key. I wanted here to highlight one of the AI use cases we have. About how I talk in natural language to my data backbone, engineering data backbone, to search for information without knowing really what I'm looking for. And I can access to all information, including the 3D. But here, in that example, I knew the number of the project. It was project P101. But here, I don't know the code name. And I just ask the last part updated this year. And so the intelligence know where to find the last part done this year. Then in the project lifecycle, you will start, after reusing what you can, to define a system approach, a system engineering workflow, starting with requirement. So we are providing tools to digitalize and move from a document-centric to a data-centric approach for requirement management using one unique agile platform, which is Polarian. That platform is strongly integrated with an MBSC approach, including MBSC modeling tool, to have that complete definition of a system and subsystem and provide you the basis of the traceability and the digital continuity through the design and the simulation. Which is the interesting part in becoming becoming data-centric from document-centric, is to put AI in your activity of requirement. And here you can see that embedded in the tool, you will have a tool providing capability to validate the fact that requirement is enough precise. And he perform a similarity analysis to check with the other requirement that there is nothing which is not too similar, and then a consistency checker to check if you didn't write something which is the opposite in the same document, to help you to have a consistent and comprehensive requirement engineering process. Then, when you perform the system engineering activity, you will move to, it could be done in parallel, of course, to a design phase, to design from a formula to automation, including PNID, mechanical and electrical, sketch of the plant. Sorry. And we provide at Siemens an integrated tool chain in order to have strong integration between the PNID, the electrical, the piping activity at a low level, and moving to the equipment definition, equipment concept, to actually define the layout of a factory, maybe a nuclear fuel factory, and at the end have the complete comprehensive mock-up of a nuclear power plants. And you can see on the left that tools are connected between 2D and 3D. This CAD model will be used then for the simulation activities to be performed in order to validate and optimize.
Exactly. So thanks, Guillaume, for that. And just building on the term of reuse, we know that there is a lot of reuse, or rather over-design or maybe repetitions in the engineering processes. And the more closer we can bring these tools and these processes and these tasks, the less we need to repeat them. So a lot of those workflows can be automated. And I'll just show you an example where we have done this with our tools. Oh, thank you. So what we have here is basically a PNID, and we have open APIs, and we can integrate any kind of third party. And that is very quickly converted into what we say, let's say, has a backend, which is an XML, and which can be quickly brought into the system and mapped to a physics-based model. So all the mathematical equations, let's say if you have n types of pumps, valves, all those curves are actually already populated in. So very quickly, you go from your design to your first validation of that design. So things like procurement, what pumps to size, when to procure them, very complex equipment that has very long delivery cycles, can be really brought up front. And one of the proof points we have actually is we worked very closely with our customers in China. So this is something that the Shanghai Nuclear Corporation did with our tools. So basically, pretty much automated the entire workflow from going from a CAD all the way to CAE. And the bigger the model, and because we are talking really big systems in terms of fluid networks here, so an engineer would sit down, design, put data in, there's manual errors. So all that heavy engineering man hours of approximately 6 months, 3 months, depends on how big the thing is, comes down to a few minutes. And it's very easy then to avoid any kind of manual errors. You can get very quick validations done very quickly. Building on that, so it's not just one thing that we want to do in isolation, which is something unique about the company, is that we have a full range of things, and they all connect to each other, they all talk to each other. So it's possible that you already have certain processes and designs or tools that you've already used, possibly in-house, but all these dotted lines that connect every aspect of your thing. So let's say if it's an actuator, the multi-physics side of that, to the reactor core technology, all the way from your classic EPRs to the fuel rods, any kind of advanced reactors, and I'll give some examples there later on. Everything around the reactor, the secondary. And the main thing is it's not lost in R&D and engineering. So a lot of these things, then they enter into a digital dump. They're never reused. So reuse, the word is easy. How do we make it happen? And really is to operationally deploy them. They have to be easy. They have to be embedded. They have to be creating value for someone who needs them on demand right there at the point of demand within 5 minutes when they have to make an operational decision. So that's why we are working on a lot of AI technologies, as Guillaume was mentioning. And one of these is to actually abstract all of these complexity and put it into our little edge devices that can sit on the floor itself and deliver a lot of value. So one of the examples here is like pretty much all our codes are complying to nuclear standards. One of the codes which is heavily used, especially for the Gen 4 reactor licensing in the US, is STAR CCM+, and we have one of our very strong customers, X-Energy, use this code to pretty much validate their new design of the pebble bed reactor with the graphite and coated fuels. The next one is also for the sodium reactors, where you have an example here with the steam generators and some kind of flowback that needs to be assessed. And this was done by the Korea Atomic to actually assess whether there is any flowback or not, and make design changes accordingly. So there's a whole depth and breadth of simulation, but then that follows back into a business process and connects to something that can be easily commercialized and makes the overall process leaner.
Yeah. we saw that we were at the beginning of the V cycle, the engineering workflows, and everything will move during the life cycle. You will have a lot of change. You need to have digital continuity from requirement through design, through simulation, and we provide the digital continuity with a backbone, which is a platform really accessible to everyone, and that will be the single source of truth and single point of access to engineering data. And that covers the link between design and analysis, but also transversal subjects like quality, supply chain, or project management. It's really where everyone will find the information. Could be document, could be tags, could be 3D design, could be the risk, could be the issue. Everything is in that platform, and it's a simplified UI, and it's an accessible tool. Here it's an example, a quick example of that platform. You will have the full traceability of the system with a relationship browser to explore what are the requirements linked to a design. You can explore your PBS of the plant, verify what is validated, what are the variants, because in modularization approach, you need to have this. You have an embedded powerful visualization tool to take measurement, to do clash analysis. You access and open and read documents in the platform to do markup, to collaborate with colleagues. You have inside the platform also the requirement. You have the project management tools like a Gantt. Everything related to engineering is in one platform, a working platform, a standard out-of-the-box platform, which is Teamcenter. You saw the Gantt and project management at the end. Something really, really important here is the document management. What we call it master deliverable register and transmittals, how I manage the document and the transmittals with supplier, with customer, how I link that to the WBS, to the work packages, to the contract, to the credit. The platform is managing all of this integrated to the engineering workflows. We define what was the engineering, but from the start, from the requirement, we need to prepare what will be the construction and what will be the maintenance of the asset. And we can prepare that virtually with the digital twin. First, we can simulate the capacity of a layout. It will be especially relevant for nuclear fuel plant or nuclear fuel cycle to validate, considering a layout, considering operational capacity, the fact that you will be able to produce. Then you will be able to virtually simulate the path planning of a construction sequence and prevent and avoid issue on the field on dedicated construction phases. You will also be able to validate sequence. Here it's a decommissioning sequence, so to prepare what will be done as a 4D approach on a project. And then again, you can reuse everything what you've done and prepare on an engineering side to train operators with immersive training solution. And the end of the loop of the life cycle is to redo it again, is to close the loop with continuous improvement and to reuse actually engineering data to supply and to perform during operation.
All right. All right. So when it comes to digital twins, and this is something that I mean shares different levels of the The first wave, let's say, is more digitization. So you have an asset, you want to put a sensor on it, you want to measure certain things, vibrations, and so on. So it's really getting the first level is an accurate state of the asset based on the instrumentation that you have. The second level would be, let's say you have some data validation techniques and basically what is coming to filter that, to have some reference on the context of that. And the third level we see now is a lot of AI being introduced into the mix. And it already is delivering a lot of benefits. We have recently acquired technologies from Altair, which have very specialized knowledge graphs built up, which can really help you leverage that kind of AI. And really, when it gets very complex or very comprehensive in that sense, we have technology called executable digital twin, which is basically taking all of that R&D work, extracting something that is away from the authoring tool, and can be hosted in any kind of environment outside of the authoring application. So we're seeing a lot of examples on this. I don't know if some of you were there at the Siemens stand today. We had one of our colleagues at Framatome give a presentation on how they've been using some of our technologies to develop that to really help their operations out. So this one example is specifically a little bit generic, but it's a heat exchanger. It's something that is common throughout different industries. So really what we're trying to get to is an asset that where you can only measure the inlet and outlet temperatures. How can you get something valuable? So some things like remaining useful life. And this is basically where we have extracted the whole detailed models from the 3D side, validated them with the test data that we have, and created reduced order models. And the beauty of it is that it's not just a cool thing to do. As it goes through a thermal cycle based on the data, you get the stress response from this component. And based on that, you can see the fatigue that it has accumulated and what is the remaining useful lives and point of failures and so on. And this is something that has already been applied by one of our customers here. And this is the Altair technology from AS Systems, specifically in the UK, for getting all of this kind of analysis into real time, into operations to really augment the instrumentation we have. And last but not least, we talked about jellyfish. I don't know if someone Googled up a jellyfish story. Assets that are very close to sea typically do use seawater for cooling purposes. And not every time it's going through distillation or any kind of refining process to get those little fishes and algae out. And it's not just to get it out itself, but it's important to understand in these networks, there are zero flow zones. So wherever you have a stoppage of flow, basically you're operating in a point where you have no flow in certain zones. That's where little marine life starts to grow. There's little algae, and if it really stays there for a long period of time, you've got a lovely little pipe with pretty much everything blocked, and everything has to be taken offline. 50 bar jets need to arrive, and they have to blow the thing out. So these things happen, and we had this example from BASF, which is in Antwerp. A very old facility has gone through a lot of retrofits, upgrades, and there's still a lot of instrumentation in the cooling and steam networks. But adding an instrumentation like a flow meter is expensive. Sometimes it's away from the DCS systems. You can't integrate that. So a lot of challenges to actually, go and understand what's happening and what's happening at scale across different scenarios. So they use the integrated approach with the executable digital twin, where they could actually have all of this information embedded in an Aviva Pi software front end, which is, we're very open to third parties, and in this case, wherever it makes sense with our customers, we work with them. So let the story play out, but it's similar to the jellyfish entering. If you have a good idea of where your flows are exiting or getting things in from the sea, and that might change depending on the operation state you're on, these kind of things can be avoided. And so can be zero flow zones by augmenting the operations. So let the video play out as a testimony of this case.
I'm Katrien Stukers. I work at BASF Antwerp. 60 years ago, BASF, Bayerische Aniline and Soda Fabrik at that time, started a production site in the port of Antwerp. On the site, there are more than 50 producers and users of the BASF utility grid. And one of the most challenging grids is the brackish water grid. It is used here as cooling water. As it is brackish water, biocides are needed to kill biology that grows in it. But these biocides may not go back to the environment as it has environmental impact. And we must also be sure that when we dose it, it reaches all pipes. An executable digital twin has a simulation or a test-based model at its core, packaged in a standalone format. It contains a physics-based behavioral model connected to a physical system in order to make calculations for flows, for pressures, for temperatures. And with these calculations, we can predict how changes would be. We can also analyze the current situation, and we can accordingly optimize the operations itself. For the automation, we didn't need to install any flow meters or pressure transmitters or other sensors, and the operators could quickly pick up the functionalities of SimCenter. As we have positive results, we'd like to extend the digital twin to other pressurized grids.
Right. So yeah, that brings us to the end of our presentation. So we have this facility in Chicago in the US where you can pretty much see all the different Siemens hardware, software, XDTs, and that's something we've done in partnership with Dow Chemicals. There's also other things like robotics, even mechanical lungs, because this was developed during the time of COVID, automatically guided vehicles growing around in a metaverse. So if you're interested in visiting the facility, by all means, you're more than welcome. Get in touch with us. And yeah, thanks for listening to us today evening. Thank you.
Thank you.
Questions?
If not, we stay right here if you want to discuss with us.
Yeah, or you can come by at the Siemens stand at C018. All right, thank you.